There are 7 rules I want to cover with you, and these rules we're going to use them to answer various questions involving angles. So the first rule many of you are familiar with, which is the opposite angle one. And we just mentioned corresponding angles where you have the 2 parallel lines. And you can also use the opposite angles to say that these are the same as well. And there's other properties that you can use, but we'll get to those properties soon. Now, let me know in the chat there, who remembers this one? All the angles in a triangle add up to 180. Who remembers that? We got one person. Anybody else? Good. Thank you. Thank you. Wow, I'm getting inundated by yeses. Good. So, have you ever thought about what if it wasn't 3 sides? What if it was 4 sides? So, I'm going to explore that with you right now. The rule is actually right here. If you have an n-sided figure, that is, if the figure has 3, 4, 5, 6, whatever, as many sides as you want, what would be the angle if you add them up inside? What would be the total angle? So I'm going to talk about that right now. The formula is actually this: n minus 2 times 180. But I don't like just throwing formulas at people. I want to actually explain to you why that is the case. So I'm going to show you how that works here. So if you want, if you're doing this in a notepad or something, you can jot this down with me. You have number of sides, and that's 3 sides. You can put a figure if you want here. So my figure could be like this, a triangle. Let me draw a really small triangle. And then the total interior angle. So all the angles in a triangle add up to 180. I think we confirmed that just by saying that earlier rule. So what if it had more than 3 sides? What if it had 4 sides? What would the total angle be for 4 sides? Anybody want to guess? How much would it be if you added up all these angles here? Zifeng is correct. It's 360. Now, if I ask you why, an explanation that is not correct is to say this: well, it's 360 because I know a square, for example, is 90, 90, 90, 90, right? You know, square that up to 360 because it's 4 times 90. That is not good logic, because this thing here is not a square. It's a general 4-sided figure. So the cheapest way for me to explain it to you, and I believe me, it's really cheap, is to take that figure and turn it into triangles. See, how many triangles are there here? So the minimum number of triangles. Thank you, Malik. Yeah, so it's 2 triangles. I drew a weird line. So there, okay? 2 triangles. 2 triangles, okay? And okay, then it's 2 triangles, so it's 2 times 180. My stylus is really slow here. I'm actually like typing things more than I do actually writing with this thing, but bear with me anyway. So that's 2 times 180. That's right. Thank you, Ram. So what if you had a 5-sided figure? What if you had a pentagon? Now, this pentagon, there's nothing special about it. It's just 5 sides. They're not all the same. There's nothing unique or special about it. It's just 5 sides. What do you think the answer is for this? Anybody want to guess in the chat? Yeah, it's 3 triangles. So what's the number, Lucas? What's the number there? Thank you, Shalon. It's 540. Good. Sorry, I'm just reloading my screen. Just give me a second, people. Sorry about that. It looks like everything's going wrong with my computer today. So that's 3 times 180. And that's what the formula is saying on the previous page. If you have n sides, not 1, not 2, not 3, but n sides, it's going to be n minus 2 times 180. So this formula, when they say four-sided, do they mean 4 lines? Well, they mean 4 sides to the figure, yeah. So if you're saying lines here, I'm talking about sides, yeah. So in general, if it's n sides, then it's going to be, look at here. How do you go from 5 to 3? You take away 2. So it's going to be n minus 2 times 180. So I'm developing the formula for you rather than just telling you the formula. And I'll do that on occasion in this course where there's opportunities for me to show you something beyond just telling you a formula. I don't like just telling you formulas. So anyway, out of the 4 rules that you see here, I would say that most students, out of the 37 that I see in the chat, I say that most students knew at least 2 of them. I'd say not many people remember this one. It's not a very common rule, and you'd have to really dig back into your memory. If you studied math in Ontario, you might have seen it somewhere in middle school or grade 9 or something, but I don't know. Definitely, 12 and 3 are very common. Okay, so let's take a look at 3 more rules. And then I'm going to show you how you can use these 7 rules in total to do many questions. And we're going to spend the remaining time today actually just solving a bunch of questions involving angles. And that's pretty much what we're going to do. It's going to be a laid-back lesson, and in all honesty, most of the stuff I'll do with you over the semester is going to be laid back. I'm just going to show you some theory and then do a lot of math with you, do a lot of application questions with you. So here's the next one. Who remembers the word isosceles? Isosceles. Yeah. So when you have an isosceles triangle, that means that 2 sides are the same. So what that means is, yes, the bottom 2 angles are also equal to each other. So that's very useful if you have triangles with symmetry. In construction, there's many opportunities for you to see triangles with symmetry. Most often when you look at, for example, a bridge or a roof or some type of structure, for various reasons, including structural reasons, aesthetic reasons, there's symmetry. You use symmetry a lot because it just ends up working out better, not just on the eye, but also on the pocketbook in terms of your cost. So there are 2 more. Yes, exactly. You can imagine this as, for example, a building, or maybe it's a roof structure. It could also represent an element within a truss or a frame, if we're talking about a structure like a bridge or a crane or something like this. The final 2 properties, which involve circles, are less known by people, but they're very valuable in terms of solving questions with more complex geometry. So this one here, number 6, is going to be the radius and the tangent. So I assume that you're familiar with the radius of a circle, so that's this thing here. But many of you might not be familiar with the word tangent. So the word tangent refers to this line here that just touches the circle. And whenever you have the situation where you have a radius and a tangent, these things will always meet at a right angle. They will always meet at 90 degrees. This is important, for example, when you're talking about gears pulley systems, anything involving a circular motion, very valuable to know that the radius and the tangent will meet at 90 degrees. The last of the properties, or if you want to call them rules, is the following here. It's that if you take a circle and you draw two tangents, so there's two tangents, the outer one here and then the outer one here, they form an angle. See this angle here? They form an angle together. Now, if you draw another line segment that starts from where the tangents meet and it goes through the middle or the center of the circle, then this original angle here in purple is going to be cut in half equally. Now, we don't say the words cut in half equally. Instead, we say the word bisect. So whenever you see the word bisect, bisect refers to divide into two parts equally. Now, you might get overwhelmed here by all of these words that I'm throwing at you. And I understand that it might be, especially for anybody that's not studying math in their first language, in English. So I mentioned that I would put a bunch of keywords on Blackboard. I should say, by the way, thank you for those that recommended the reset. It looks like the computer is a lot more stable. Frankly, I don't think I ever reset my internet since I moved in here. I've had Rogers here for like 6 months now, so go figure. But let me go to Blackboard. I did put a file here for you to look at, and it's important that you I don't you have to print this out, but think of it like a checklist. So I believe it's under the course notes. No. Here. It's under lecture slides and extra commentary. And it's this one here. It says keywords for chapters 1 to 4. Don't worry. I'm not going to give you a test and say, you know, read the dictionary for me and define a bunch of stuff. I'm not trying to do that to you on a test. I might give you like some question, maybe a few fill in the blanks, something easy, but this is more about communication. And in this document here, I've included just a single page from an old review package that I had at the request of some students that were like, okay, what are all these words I need to know? So you're very welcome. So here they are, and this is all the key words that you might encounter in the first booklet, chapters 1 to 4. So we're somewhere in here. So let's see if we've used any of these words. So it looks like we've used the words radius. See radius, tangent, isosceles triangle. Oh, there's that weird formula I just proved with you. And then we had a bunch of stuff from last time, like obtuse angle, acute angle, reflex angle. Like, so if you look at this list here, let me do my math here. It's 9 times 3. There's 27 boxes here, and I bet you that if you got a marker and you were to like erase a bunch of them, hey, I can't give you everything, right? You gotta know some of them anyway. But they're all in the book though. But anyway, out of these 27 things that I've shown you here, these key words or phrases, it's important that you make note of the ones that you didn't know. Don't write down the stuff you know. A lot of times I find when I was a student, I waste a lot of time writing down things that I know already. And then I realize that I'm wasting time that I could either spend maybe resting or doing something a bit tougher. Anyway, those are the 7 rules that we're going to talk about in terms of using them for application questions. So, are there any questions about these 7 rules before we proceed? Very good. Thank you, Amira. And oh my God, who was on that streak? Shalon, you're on a streak there. Oh my goodness. Okay, so I gave you my perspective. 7 again, please. Absolutely, Sifeng. So again, for number 7, the idea here is that if you have a circle and you draw 2 tangents, so here's one tangent And here's another tangent. These tangents form an angle. See this angle here in purple? Now, if you draw a third line that goes through the center of the circle from where the tangents meet each other, it will cut the original angle here, purple, it will cut it in half. And we call that process of cutting something in half bisecting. You can cut different things in half. It could be an angle, a side, a line. It could be a picture. It could be a whole bunch of stuff. So that seventh property is very interesting, but it's also very useful in terms of doing some application questions. So I gave you my story on those 7 rules, but if you go to page 10, page 11, page 12, those 3 pages are the author of this book. It's his perspective. It's his story explaining the exact same thing that I explained to you. So for that reason, I'm going to ask you just to read these 3 pages. As you know, these notes that I'm showing you here that are annotated, that I'm drawing stuff on, I'm going to post these on Blackboard at the end of class today. So you'll have an opportunity to read over what I said to you during class, and you'll also have the video to watch, which I'll post on YouTube later on tonight. So I'm just going to say here, read. And I'll say it like I'm yelling at you. Read, okay? Read. No. Do you find that offensive when I write it in capitals? Is that annoying to you? Sorry if it is. Okay. Okay, I'm not trying to be like all like aggressive and angry and stuff. I just find it funny. Anyway, I think you get the point. So just read those. Okay. Yeah, I'm gonna put the video on. Maybe my computer won't crash if I put the video on now. Okay. Yeah, you never know. I don't wanna upset anybody here. We're online, right? I can't see your reactions. Usually in class, people will be laughing, cracking jokes, you know, high-fiving each other. Anyway, look at this. If you go to page 13, there's a whole bunch of these questions where it's like, find the angle, find R, find S, find T. Look at all these angles. Oh my goodness, overwhelming. Saturation of angles. So what I did was, and what I usually do with the class, thank you, Alex. What I usually do is this. It's prohibitive. It's not possible for me to answer every single question. Also, this booklet is your homework. So any ones that I don't show you, you should try them on your own anyway. So what I'm going to do is, based on my experience from past semesters, I just pick some random questions and I'll do them with you in class. So from these questions here, I grabbed a few of them. I actually grabbed 6 of them. So I, without any bias or like, you know, like secret agenda to do the easy one with you and give you the hard one on the test or something. No, none of that. No BS, okay? I just randomly, and I swear to you, I just randomly picked 6 questions. So we're gonna do D, G, H, and then we're gonna do I, J, and K. So 6 questions from that sheet, and then we're gonna dip over to page 14, and here's some more nastiness. Oh, look at that. That one looks funny. Look at F. We're gonna do those 3 as well. I chose those 3 from that page. And then by that time, you're probably gonna pass out from exhaustion from us doing so many angles. But anyway, it's gonna be a low-key lesson. We're not gonna hurt anybody's head here. So for the sake of making myself deliver things well here, I'm gonna just type the answers because I find with the stylus it doesn't really work very well. So anyway, all jokes aside, let's get to business. So any questions I don't cover with you from page 13, you're responsible to do them on your own for homework. And the answers are in the booklet. So let's take a look at question D. All questions here are asking you to solve for the indicated variable. So in this case, the variables are X and Y. So we're trying to solve for these guys over here. Trying to solve for this one and this one. So I'll do some math here on the side using a text-based solution here. So anybody want to go out on a limb here? What do you want to do first? Do you want to get X or Y first? Let me know in that chat. I agree with the mirror. Let's get that Y first. Now, the good news is, I promise you, I'm not going to make your life miserable. I remember I had some pretty hardcore teachers in school, and they're like, using property number 3, like that. I'm not going to do that to you. Don't worry, okay? Instead, what I might do is just say this: opposite angles, and then just say y equals, in this case, 85 degrees, okay? Is that reasonable? Is that too much to ask from you? One statement saying what it is, and then one with the answer. How would you get X? What property could you use here out of those 7 rules earlier? How would you get X? What shape is this? Thank you, Zifeng. Thank you, Ram. So, yeah, you're on point with that. You want to use 180. So, everything that you said, those 4 comments are excellent. I'm going to take all of those things and put them together into one story. So, I'll start with the mirror statement. So, I'll say that angles in a triangle. And we know that means angles in a triangle add up to 180. So, x plus y plus 60 equals 180. Now, I'm going to be a little bit lazy here. I'm not going to put the degree symbol until the very end. But you should always put the degree symbol because it's good form. So I might fill them in later just because I'm a little bit OCD, but nothing too dangerous. So anyway, we do know what y is because we know y is 85. And at this point, you're just doing algebra. And there you have it, my friends. I'm not asking you to write this much. For anybody in the class here that's wondering how much do I need to write, the stuff that I'm highlighting over here, I want to see maybe I want to see at least one of these steps. I want you to show me at least one calculation in between to prove to me that you're not just guessing the answer. Also, let's just say that you did not write this stuff here. If you just wrote x equals 45, that answer is wrong, right? How do I know that you got a mistake because of silliness or because you had no clue? By silliness, I mean that you made a silly mistake. Is it 85 because of opposite? Yes. So I'm not asking you to like state the theorem. Like over here, angles in a triangle. If you didn't write that, but you wrote this, I'm pretty sure you understood the logic that it's the triangle. I'm not out to get you, I want you to show me a couple of steps for each of the calculations so that I know that you know what you're doing. That's all. I'm not here to pick on you or anything like that. Okay, so over here, what type of shape is this? What type of shape is this? Be more specific, Michelle. You're right, it is triangle. What type? Would you say it's equilateral? Thank you. Very good. Thank you, Michelle. And Amira and Hamza. Oh my God, Hamza's on fire right now. Look at that. Okay, so yeah, because it's an isosceles triangle, we can immediately say that the base angles are equal. Sounds good, Mike? I got 180 students this semester, and it's actually easier to learn your names through the chat because of the way that I process things in my brain. I'm very bad with names and faces, but I don't know, whatever. let's not go there. Okay. Uh, kind of hilarious if you're a teacher, right? Anyway, y is equal to 64. I am totally in agreement with that because of the base being an isosceles triangle. And then, of course, all angles in the triangle add up to 180. I'll just say triangle 180 rule, okay? So for that, we can say that we have x plus y plus 64 is 180. I love the communication in the chat. You're doing all the legwork for me. So x plus 64 plus 64 equals 180. And definitely you can cut corners here because this is 2 times 64, as I'm seeing with Shalon's answer. I'm just trying to do it in as primitive a way as possible so that everybody that is in this group here can be assisted. What do we got here, 52? So the thing with this is that, you know, if I was in class writing this on the board, I probably will not write this many steps if I'm writing it on the board, just because I would not have enough room to write all this stuff on the board. But when we're doing this stuff here online, it's kind of cool because I can write down all these steps because I don't mind writing them down, and it's really, really quick to write them down. So I don't mind if I go silent and I just write down a little bit of algebra on the screen. It's a win-win because you get all the little steps in between for those people that really want to see those steps. But you don't have to write all this stuff down. I'm not asking you to write all that stuff down. So don't worry, like if you're like, oh my goodness, this guy wants me to write 10 lines of writing. Okay. How do you feel about the pace? Let me know in the chat. Is the pace okay? Matthew, thank you. Matthew, you don't we need to? Yeah, exactly. You do need to know the steps for sure, Matthew. I'm just saying, like, I normally don't write down this many steps. If I was teaching this in class, what I might do is I might write this on the board, and then I might write this on the board, and then I might just write this at the end. I wouldn't show you this. And the reason I wouldn't show you every little step is because it's true, Matthew. I get your point, but it's also the fact that this is Math 1146, and in the previous course, you did that stuff. So it's like, I don't want to fall into teaching you stuff that you should have learned last semester. So I'm kind of balancing out the two things. But yeah, don't worry. I'm not going to leave you in the dust here if you're like, in terms of writing steps down. I'll be very diligent with my explanations. Just sometimes if we're trying to answer 10 questions in the time that we have to answer 5 questions, I might show you how to set them all up so that you can finish these things off yourself. But that way, at least you have your foot in the door, so to speak, for all the questions. Instead of having one nice answer, you have 5 answers that are almost done that you could finish off anyway. That's what I'm trying to say. Okay, internet connection issue again. I'm going to turn my video off. So, looks like something's up with Rogers. Anyway, let's go to this next question here. Any comments on this next one here? What type of triangle is this? Is it isosceles? Yeah, it's the same as above. So what do we know about U and V? How are U and V related? Thank you, Amira. U and V are the same. So we could say the following. I'm going to do something a little bit creative this time. I'm going to say that U equals, well, I already wrote it there. Actually, forget creativity. Let's just write it down like brute force. So 122 plus U plus V equals 180. But because U is equal to V, because U equals V, yeah, exactly, Hamza. That's the way that I'm going to answer it in a second. But for now, I'm just going to do this. I agree with exactly with what Hamza is saying. But I'm going to do it this way first, then I'm going to show you the shortcut after. That's what I was saying. Remember, I was saying it before, Hamza, and then I cut myself off, and I was like, wait a second, let me just do a brute force, and I'll come back later. So yeah, so I'm going to do here 122 plus u equals 180. Whoops. So that's the way that I would answer it in terms of just powering through the question. The other way is the shortcut, and I'll type the shortcut right here. I'm not going to do it as a formula. I'm going to do it as a thought process. Just a second. I'm just typing something in here. U and V are. That's kind of like what I got in the chat there from a few students. So that's exactly what I'm going to do as well. I'm going to take those words that I said there and just write it in text in here. So U equals V equals 180 minus 122 divided by 2, which is 29 degrees. So this is how I would answer it myself, actually. I would just write that. So if that's appealing to you, if you like what you see there, the purple thing here, if you like the purple, do it the purple way. If you don't like that, then do it the more orthodox or traditional way over here. This is kind of like the brute force algebra way, and then this is kind of the be creative way. Purple rocks, yeah. So, hey, actually, you know what? Let's see. Let's talk about some colors here. Okay, so I'll call this one here blue. Okay, who likes the blue way and who likes the purple way? Let me know in the chat. Blue or purple? So we kind of got, if I do the weighted average here, oh, we got more purples. Wow, I don't mind. We got a couple of neutrals. I got a Mike. Mike's got a either. George is either. Ram is either. Okay. So the good news is as long as you can do it one way or the other, it's all good, right? As long as you can do it one way or the other, you're safe. Just do whatever you feel is safest to do. That's all I always say. I always go with the safest play, especially when it comes to doing stuff under pressure. If I'm going to do any math under pressure, because I can do some crazy math in my head, but I don't want to do it in my head unless I have to. And if I do it in my head, I'm going to do it the way that's the least difficult for me. Yeah, under pressure, I go with blue. Absolutely. I don't know if you can. I'm going to put the video on. If it keeps on complaining about my connection, it doesn't matter. We're going to take a break soon anyway. But I got to tell you guys. I got to tell you guys a little bit about how I think about things, because I think it might help you too. When I did math all my life, I was pretty good at math. Otherwise, I wouldn't be teaching you anyway, right? But when I did math, the first thing I always tried to do was get the answer correct. And then once I had the answer correct, then I started getting creative and saying, oh my goodness, I can do it this way. And now I can do it this way. And like the purple way is kind of like being different and creative. But what I always did first, above all things, was get the answer right. And then after that, you can be creative. So that's what I always say to people is get that answer right, build up your confidence, and then be creative about it later and figure out alternative ways to do things. So I think we can do some more. It was I'll tell you something. Actually, you know what? Since we're there, okay. Since they were there, Shalon is asking a question here. I don't want to. I think you know what, everybody. Let's take a break right now until 11:05, okay? But I'll answer your question, okay? 11:05, okay? Break till 11:05. But I'll answer Shalon's question anyway. No, Denny, all good, my friend. Because I was having tech issues too. I gotta tell you, you know, some people they get math quick, right? And then there's other people that work at it really hard, but they get it in the end. Do you know what I'm saying? In the chat, you don't have to tell me about yourself. That's private. I understand. But I understand that there are people here that get math quick, and there's people that work hard to get it. Okay? And I believe that if you have either of those things, that's amazing. But then there's the thing. There's the thing. There's some people that get it quick and they work hard. And I was lucky enough to be one of those people that gets it quick, but I also work really hard as well. Now, you're saying people that just don't get it. Matthew, I got to tell you, I've helped a lot of people over the years, and I'm a strong believer in pressure and time. It doesn't matter. All right, thank you, everybody. I will get going here with some more examples. So let's get it. Let's do this. So let's do some of these more algebraic ones, and then we can proceed. Again, I apologize to anybody showing up a little bit late today. My internet's been cutting in and out on the quality. So if you see the screen that I'm sharing disappear, don't worry. Just give me 5 or 10 seconds to fix it. Anyway, this triangle here, this one here, there it goes again. This triangle here, is isosceles. Yeah, I don't have any other apps open right now. It's just this. It literally is just this. I wonder if my computer is doing an update in the background that I don't know of. Anyway, so this is an isosceles triangle. So I'm going to write an equation here, and I want you to think about what I'm writing here as I prepare it. So let me know, what do you think about that? Why did I write 2x twice? Why did I write 2x twice? Yeah, I think at this point, Matthew, I'm just going to let it slide. I'm just going to let it slide, and if it keeps on cutting out, it is what it is. Okay. I think it might be Blackboard, because it's saying my internet. My internet's pretty robust. I was just checking it on during the break. I did an internet test on my phone. So I think it's Blackboard, to be honest with you. Anyway, X is 36. So again, I apologize for that crustiness. What I might do is, what I might do is, I'll do some more examples with you. But if it keeps on going like this, if I might dismiss you a little bit early, and then what I'll do is I'll just record a bunch of, yeah, you can do the rest on your own, but I'll record some more, I'll record some extra ones by myself, just in my studio here, and then I'll put them together with this stuff and put it on YouTube. No, not really, Matthew, because I will edit. I always edit the recordings. So I take these raw recordings and I edit them, and then I put them through and put them into YouTube. Yeah. Oh, you're welcome. No, I don't wanna come back to this stuff next time. I wanna have it so that I solve it for you. So anyway, let's just keep on going, because I want to just keep on going. I don't want to waste time, like wasting your time talking about things. Yeah, I put them on both. The raw recording is on the files here, and then I also edit the video and I put it on YouTube as well. So you get both. You get the YouTube video and you get the raw video. But if you go to the YouTube, well, now it is. Wow. Anyway, let me try answering a couple more, and then what I might do is I'll just, yeah, the video is very easily identified because there's a folder on Blackboard that's showing for a second, okay? Just bear with me. Just give me a second, okay? If I lose connection, don't worry about it. Okay, everybody, can you hear me again? Okay, let's get going. I tethered it to my phone, so it should be okay now. It is what it is. Anyway, in this case, we have these angles here, and we want to solve for x. So we know that the angles add up to 180. So we would have here x plus 30 plus x minus 15 is 180. I think it should be okay now. I'll definitely be giving Rogers a piece of my mind today. So this is 3x plus 15 is 180. Let me know in the chat, do you need clarification about what I just wrote down there? Okay, Sarah, so what I'm doing here is I'm saying I want to solve for x. So, and George, the angles here, these three angles, whatever they are, they have to add up to 180 because it's a triangle. So all angles in the triangle add up to 180. That's what I'm doing here. That's the logic of what's happening here, okay? So in this case, if we take all the like terms, we have x, x, and x. So we have three of those. So that's three x's. And then we have 30 take away 15. So if you want, I can rearrange it like this. X plus, whoops, x plus x plus x plus 30 minus 15 is 180. And now you can organize it by like terms. So you'll have three x's and then 15 and equals 180. We can move the 15 over and get one. Good, I'm glad that you got it. So if we divide by 3, we get 55. So 165 divided by 3, so x equals 55. Now, unfortunately, this question is not finished. What is the question asking? Because we didn't really answer the question yet. See that? Find all three angles. So the answer, yeah, that's right. You just got to go back and substitute. So the answer is right here. So the three angles, are x, x plus 30, and x minus 15. So we have to plug in x here to be complete with the question. So the first angle is definitely 55. The second one is 55 plus 30, which is 85. And oops. And the last one here is 55. Thank you very much. 55 minus 15, which is 40. And that, my friends, is a complete answer. So it's important that you finish up with that as part of the answer, because I'd hate for you to get a question and you get this far, and let's say the question's out of 5, and then all of a sudden you end up getting 4 out of 5 instead of 5 out of 5 because you forgot to go back. Anyway, it looks like the internet stuff has resolved itself because I'm using my phone instead of my home line. So it looks like it is the home internet connection. That's good news. Anyway, we're off to this question here now. This question's looking a little bit crusty. We have this embedded triangle here. And there are 4 variables to solve for. So there's w, x, y, and z. Now, doing this question could pose for a little bit of trouble. So I'm going to actually do this one on the next page because it's looking a little bit annoying. Let's get it nice and big here. So my advice to you here is to notice that there are three triangles that are separate. There are three different triangles, and they are isosceles. So I'm going to call this triangle number 1, triangle number 2, and triangle number 3. So let's talk about these triangles separately and see if we can make heads or tails of things. I'm going to start with triangle number 3. I can see that W over here is the same as this angle over here, and that angle up there is 118. So we have 2W plus 118 equals 180. So what do we get there? Well, someone's already solved it, 31. I'm going to go through it slowly here. So is that 62? And yes, that is correct. W is 31. So 1 down and a few more to go. From the inner triangle up here, number 2, we can get Z. So in this case, we have Z, 52, and can you see where my cursor is right here? What angle is right here where my cursor is? Where my mouse is? What is this angle here? Thank you, Ram. What's that angle that I have there? It's not labeled on the triangle, but what do you think it is? It's a number. It's 52. Donato, thank you. It's 52. Yeah, because this angle here is the same as this angle here. Just like this angle here is the same as this angle here, which we call W. And if we want to go a step further, let's call this a triple. This angle up here is the same as this triple one here, which I'll call X. So good that you pointed that out. So we have Z plus 52 plus 52 equals 180. Now, I know some people are getting annoyed. They're saying, hey, John, why don't you just say 2 times 52? And I'm going to say, because I feel like doing it that way so that I see 3 things always. So that's why I always do it like that, because I want to make it look very obvious to me and to you. Okay. Z is equal to, what do we got there? Can someone confirm 76 in the chat? Let me know in the chat. Did you get 76 as well? Thank you, Amira. Okay, so what the heck now? Now we're off to triangle number 1. Triangle number 1 is looking pretty hopeless. What do you think? Is it looking pretty hopeless? Because in triangle number 1, there's just numbers. Sorry, there's no numbers. So what do we do here? How do we get our foot in the door? How do we get to triangle number 1? Because right now, when I look at triangle number, okay, so you're on the right track there. You got to do something with this 118. So here's a rule that we didn't discuss today, but it's actually very, very, Tommaso, you guys are, it's like playing hot and cold. You're getting warmer. I'm going to circle these 3 guys here, okay? If I circle these 3 angles here, what do those angles add up to? Let me know in that chat.
360.
Yeah, that's right. 360, okay? That's tricky, eh? That's a little tricky one. So y plus z plus 118 equals 360. And we know what z is, so that's y plus 76 plus 118 equals 360. And now it's a matter of you just kind of running through the numbers here with me. I don't have, by the way, I don't have a calculator in front of me. I'm relying on you in the chat to confirm that I don't screw up any of my calculations here. So I get 194. Can someone confirm all these numbers as I type them? What do you mean I don't need that? Oh, the calculator? Ah, I see what you're saying. You're hilarious. You got me there for a second. 166, yeah. Keep in mind here, I got a little bit rattled earlier with all the internet stuff because all I want to do is teach you guys, not deal with internet BS. I hate dealing with technical garbage. As an engineer, I don't like technical garbage. If I encounter stuff that's technical that doesn't work for me, I usually redesign it myself and do my own thing because I get very annoyed easily with bad technology. Anyway, how the heck do we get x? How do we get x? Well, I think at this point it's okay. We just do inner triangle number 1. X plus y equals 180. Yeah, I can switch to them Matthew. It's just that policy is I need to use Blackboard. So unfortunately, x plus y. So we know that's 2x plus y is 180. So 2x plus 166 equals 180. I'm just going to say the answer here. Oops. Tommaso, what's the question? I'm not sure. X equals W. No. They're not the same. Yeah, Tommaso's comment here, very good question. These guys here are not the same. They're not the same because they're separate triangles. These triangles are nothing to do with, like, if some of you might be thinking that triangle number 1 and triangle number 3 are the same triangle, but they're not, because the angle here was 118, but y was 166. So they're 3 separate triangles, and it's very important that you mention that because don't assume anything. Yeah, x is 7 degrees. Thank you for completing that for me, people. So there's a crusty question. That's a really crusty one. But anyway, something to review that you can go back in the video and explore. So I do like to do, I'd like to cover 5 more questions. We'll see how it goes. So if you don't mind, I'm just going to power through to the next question now. Just doing a little bit of housekeeping here. Okay, let's talk about this question here. Well, I'm glad to hear that, considering all of the challenges that I've been trying to deal with. So I'm really happy that it's not been a disaster. Talk about working under pressure, eh? If I've learned one thing in life, the last thing you want to do in a tough situation is panic. Anyway, this question is looking really annoying because it has features to it that are a little bit misleading. There's 3 angles that we want to solve for, and those 3 angles include P, Q, PQR. So unfortunately, a very common mistake people will make is that they think Q and R are the same. This is not true, okay? Do not assume that these 2 angles here are equal to each other. These 2 angles are not the same with each other, okay? They might be because of luck, but not because it's always true. And over here, these 2 angles, P and 37, they might be the same, they might not be the same, but don't assume that they're the same. So I just want to get that out of the way, that these 2 angles here are not the same necessarily. And if they do become the same in this question, it's because of just luck. It's just lucky. So what we're going to do is we're going to draw a different triangle and solve this question. So what I would recommend you do, just a second there, okay? I'm just going to, whoops. I recommend that you start with this picture here. Start with this little picture here, and then we'll talk. So this is 32. And I want you to find these two angles here. What are these two angles? So the bottom two are the same, yes. So what are the angles? They are 74 for that comment there, yeah. So these two angles at the bottom of the isosceles triangle, so it's 180 minus 32 over 2, which is, what is that equal to? 180, 148, 74 is correct. Can someone confirm 74? Shalon, thank you. Can someone else confirm that as well, so we're good? So now that we know they're both 74, okay, good. So now that they're 74, you can go back here and do some extra work here. So now becomes the fun part of the question. We know that P plus 37 is equal to 74, and P equals 37. Not because they're necessarily the same, it's just lucky that they're the same, okay? I'm going to mention that here. It's just lucky that they are the same. Okay, I want to really emphasize with you that it's just luck. It's not special. Now over here, we also know the following. We know that we can get R from the little triangle, from the inner triangle at the bottom. Use the 180 rule to get R. So R is going to equal 180 minus 37 minus 95. Can someone in the chat give me a number on that? What's R going to be? Can someone else confirm? Thank you, Lucas, too. So I need, when I ask for the calculation, I appreciate it, but I need to see more than one person say it so that it's guaranteed, you know, like if it's just me saying or one other person, it's not very democratic, I guess. Thank you, Julio. So there you go. You got R is 48. And finally, to finish it up here, we know that Q and R add to 74. So we know that Q plus R equals 74. So here we have Q plus 48 is 74. So Q equals 74 or 48. 26. Confirm. Are we good? Thank you, Lucas. So let's talk about the process here, because it's kind of like Lego, you know? So that was step one. That was step two. But this just as well could have been step two. So don't worry, I do know how to count. The reason I'm calling them both step two is because you could have done them in either order. So yes, I do know how to count. Please don't laugh at me. Usually when I number steps in the question, I number them in the order of priority or rank. This next question is interesting because it's the rule that I haven't talked about with you yet in terms of applying it. So do you remember that rule that we created the formula for? I can almost guarantee you that you will need this formula for assignments and for sure on your test. So make sure you know this formula for both your assignments and your test. Now, when you look at this polygon, how many sides does this thing have? Count how many sides it has. 8. Let's count them up. I agree. Yeah, we got 8 there. Thanks, Mike. Got 8. All right. So we know that all the interior angles total 8 minus 2 times 180. Can someone calculate that on their calculator or whatever? So 6 times 180. I got 1080. Is that right? I'm trying to do this in my head, but it's a little slow for me today. Okay, so, well, the question here is that we want to solve for x. So we want to solve for this guy down here. So let me show you something now, and then I'll talk about why it's wrong, okay? This is really important. This is the incorrect solution. The incorrect solution is to do the following. 45 plus 95 plus 95 plus 60 plus 35 plus x plus 80 plus 40 equals 1080. Let me know in that chat why this is the incorrect solution. Why is that incorrect? It's not 60. Ram, you are correct, my friend. So there's a very important word in this formula. Interior. What does the word interior mean to you? That's right, Lucas. Some of these angles are on the outside. So this angle here is wrong. And this angle here is wrong. So this, where is it? This one here, bad, and this one here, bad. Yeah, I didn't write the degree symbol yet because I'm a little bit preoccupied with the, I'm sorry? Matthew, what is the y about? Yeah, that's why the formula is important. I'm not sure why Matthew's asking why. Oh, I just didn't write the degree symbol because I'm being lazy. Is that okay, Matthew? I'm being lazy. I usually write the degree symbol at the end. Sorry about that. It's a little bit of a pain typing in the degree symbol. Like, as you can see here, I got to type it in 9 times or 8 times. So you can appreciate, anyway. Okay, so I'm going to just delete those for a second. Anyway, the correct solution, all right, I won't say it's a solution, I'll say approach. Yeah, honestly, for just at the end is fine. If you put degrees at the end, I'm good. If you don't put it on the intermediate steps, it's okay. You'll see that even earlier. See here, I didn't write the degree symbol. I'm not here to pick on you for that because those are just calculations anyway. But yeah, you should put the degree symbol if you're not sure. Now, no, you won't lose it until the end. And I'm not that picky, guys. Honestly, I'm not that picky. So we need to correct it. So let's talk about the correct approach. So this 60 here, it should be 360 minus 60. And this 40, I'll get to that in a second, should be 360 minus 40. So the reason it's not correct is this. So you're asking me why. This formula is about interior angles. The word interior means on the inside. This 40 here, notice that it's on the outside. Because the reason you do 360 minus is because you want this angle. See that angle there? Look at, it's like Pac-Man, like the video game, right? We need this angle. Sorry, just a second. I gotta take a sip of water. Excuse me. So this angle, the reason I use 360 is because this is a revolution. So what you want to do is find this angle here. Let's call this, see this angle here? I want to give that a name. I'm going to call that A, okay? I know that A plus 40 is 360. That's what I'm trying to say to you, okay? That's that A one there, okay? A for Anthony George. I like that. Yeah, so it's always a revolution. You're trying to get 360 there. So that A plus 40 is 360, so then A equals, okay? So that's what I did there. That's this one here. It's a reflex angle. Thank you for using your words. At this point, everybody, it's just a matter of just adding some stuff up. So 45, 40, 95, 95 plus 300 plus 35 plus x plus 80 plus 320 equals 1080. Someone please add up the numbers on the left side because my brain is fried right now. Add up all these numbers for me. These 5 numbers plus 400 at the end. I got 860. Can someone confirm 860? No, that's not right. It's not 860. No, Matthew, I was just saying to add up all these numbers. 970, thank you. Like I said to you, I'm a little slow today. So x equals 110. I think that's the right answer. I remember that answer from last year as 110. Sweet. Thank you, Amira. Oh my goodness, what a marathon that was. So I just for future purposes, let's start off. We'll start class at 10:05. Is that okay for future purposes? I'll make an. I'll be in class at 10 o'clock. You're welcome. I'll be in class at 10 o'clock. Doesn't matter. But I won't start teaching you new stuff until 10:05. The only exception is with the tests. Your test, whenever that is coming up, I'll tell you in the announcements exactly what time the test starts, whatever. I might start the test at 10:15 or something. You know, like tests are different, and anyway, we'll get to that at some point. I'd like to move over to some other stuff. Matthew, I haven't designed your test yet, but your tests are only going to be worth 15%. 4 hours? No, that's too much. That's way too long. How long was the test? How many pages? How many pages was your test? 9? 10? Oh, wow. No, I understand what he's doing. So my tests are a little bit different. Everybody, just so you know, my strategy for your tests is going to be a little bit different. Okay? Just so you know. I'm just letting everybody know in the chat. The test that I'm giving you will be different than what that Professor Anthony George is giving you, because obviously we're doing different stuff, right? I plan on giving you a test that's 1 hour, but it's also going to be like maybe 3 pages. You know what I'm saying? Yeah, yeah, but it's going to be because the test is only worth 15%. Your test is basically a long quiz. It's 15%. It's not 40%. Don't quote me on that, Shalon, yet, because I don't know. I haven't written your test. I haven't created it yet. But I plan on making the test about probably 3 pages. But in terms of questions, no, it's doable. The tests are doable, honestly. I'm not known for destroying people. Matthew, the test, there's reasons why I have, yeah, Matthew, I'm not fixated on 1 hour for your test. Don't worry, Matthew, okay? I'm not fixated on that time. It might be longer. I haven't decided yet because, like I said, I'm not giving you as long a test as the other professor is. So I don't worry about that. There's nothing really to worry about. I promise you, I'll be very, very fair with how I test you. I'm always fair with people how I test them. Okay. Yeah, so just don't, yeah, you will have enough time to do it. I have a lot of experience teaching. I know how to make a test so that people finish in a reasonable time and without me doing any like adjustment. Yeah, the test is on class time. Jifeng, the test is on class time. Yeah. That's the only limitation I have is that I want you to write the test during the class. So that's why it has to be less than 2 hours because the class is 2 hours. Yeah, no, definitely I am fair, and so is Professor George. You'll see this. I'm confident with that, okay? I'd like to do some more questions before we wrap things up today, if you don't mind. So let's do a couple more here. And the test is far away, so I don't want you to worry about tests. Let's worry about learning right now some stuff. Okay, let's go to question E here. Let's go to question E here. So here we have another property that we haven't played with yet. So take a look at that. What the heck is going on there? Can anybody tell me, is there a relationship that they know that X and Y has? Ah, tangent. Yes. Tangent line. Very nice. So if I go back to the rules here, let's go back to those rules. Where are we talking about rule 6 or 7 here? Which of the two rules? 6 or 7? Choose wisely. Okay, I got someone saying a 7. Anybody else want to talk on that one? No, I'm not trying to mess with you. I'm not trying to mess with you. Is it a 6 or a 7? Uh, I'm not playing mind games. Oh, we got people shifting to 7. Look at that. Human psychology in action. I'm totally messing with you now, eh? Totally messing with you. It's actually rule 7. It's rule 7. You had it right the first time. Don't let your professor here mess you with his mind tricks. Okay, so we'll just put that right here. So rule number 7, okay? So what that means is that we can conclude here that using rule 7, x equals y. So what we have here is that what's this angle? Let me know in the chat here. What's the angle here? What is this angle? Boom. This one like that. Whoops. What's this angle equal? I can't draw it today. There we go. What's that angle? Thank you, Malik. Yeah, that's 180. So I think we're good to go here now. Let's do this. So we have here x plus y plus 66 equal to 180. But we know that x equals y, so that's x plus 66 equals 180. 2x equals, what is that? What's 180 minus 66 is 114. So x equals 57. And we can therefore say that x and y equals each other. So x and y are both equal to 57. Success. Win. Winner. Gagnon. I love that hilarious when they say that the lottery thing, whatever. Anyway. Okay. Anyway, you remember we did this question earlier? where is it here? Okay. Remember this question here? Question K? So this question over here, if you want to see a remix of this question, look no further than this question here. That's basically the same question, but it's using Rule 7 a bunch of times. So this question, I would gladly take it up with you. And I might do that actually. I might just record the answer to that one. Let me just record the answer to that one and post it at the end of the video for the YouTube channel, okay? So I will answer this one later. Let me just say that here. I'll answer this one at the end of the video on YouTube. Okay? Let me take a screenshot of it, and I will deal with this mess later. So let's go down here, and our goal is to get to page 16. So I'm going to finish off today's class by doing maybe one more question or a couple questions, and we could continue this next time. So my goal is to finish off this booklet on Tuesday. So on page 16, there's just a couple more. Well, there's some more exercises here that are trickier. They have an octagon here. And then you got this funny looking shape here. So I'd like to answer maybe one more of these or maybe a couple more of these before we finish today. So let's take a look at this one here. That's the octagon. There's Ricardo, in terms of being due, do you mean like for marks or just being due for like being on schedule? Okay, Ricardo, none of these are due for marks. Thank you, Shalon. None of these questions I'm showing you today are due for marks. But in terms of schedule, your goal, you're responsible for everything up to page 16, okay? So if wherever we end off is where you're responsible for the next class. So after we're done class today, I'm going to take this PowerPoint presentation that I've been drawing things on, and I'm going to turn it into a PDF and put it on Blackboard. So then you can go to Blackboard later, and you'll see where I've marked up all the pages, and you'll know that that's where you need to get to yourself. So if I'm going to cover a couple of examples from this page, then you know that's where you got to get to. Also, thank you. Also, in the course outline, I give you a week-to-week schedule of what we're covering, so you know exactly how far you need to go in the booklets. So let's talk about this octagon here. You're very welcome. So what does regular octagon mean? Can someone talk to me about that? What is the word regular? Yeah, so octagon means 8 sides, and regular means, so it's 8 sides. All sides are equal. Consequently, all interior angles are equal. So I'm going to answer question K here because we know how to do total angle inside a polygon. So this is n equals 8 sides. We saw this earlier with that funny, remember that funny shape that we did? This one here. Remember this shape here, the funny one that had 8 sides? What was the total on the inside? Remember it was 1080 over here? So actually, I can recycle the calculation. So I'm going to go over here to this thing over, and I'm going to say that I can just recycle that math. See? All the angles total 1080. It's the same question. So then each of the interior angles is the same and is 1/8 of the total. So therefore, K equals, sorry, what's the question? Can you run that over? Okay, so what I'm saying is that the total of all these angles, if you look at all the angles on the inside, let's mark them up here, right? You got 8 of them. 1, 2, 3, 4, 5, 6, 7, all 8. See? If you add all 8 of them together, you get 1080. But they're all the same. They're all the same because it's regular. So because it's regular, then they all have an equal share of the 1080. So if you take 1080 and divide by 8, that will give you one of these angles, which in this case is labeled K. So I'm talking about this angle here. That's what I'm doing right now. You can add them all up because you know that they're all the same. That's why. They're all the same. So if you take 1080 and you divide by 8, can someone do a calculator on that, please? I got 135. Can someone confirm 135? I'm doing it in my head. Thank you. Thank you very much. Okay, now H is a little bit weird. Angle H is weird because it's not, it's just weird. Okay, so let me draw it on the figure. I want to use fancy words with you, but sometimes when I use fancy words, it doesn't make sense. Who has another class of 12? Everybody? Oh my God, you guys are getting destroyed. Oh my goodness. Okay, anyway, I'll record the answer to a couple more of these. Don't worry. If you got to bail out, you can bail out. I'll just finish this question, and then I'll answer a couple more. Okay, so yeah, that's fine. So you can see why it's important for me that I make your test a certain length of time. Because of the what do you call it? Yeah, no, I know it's my internet connection again. Wow. All right. Anyway, you guys can go. I'm just going to finish discussing this on my own, even if it's by myself. But I'm just going to mention here, H, if you extend the figure, H is 90 degrees because you can extend that figure. Okay, so for those of you that got to go, you're free to go. Yeah, I'm going to definitely add it to the recording. Everything everything will be in the recording, don't worry. I just have to do some editing because of the silly stuff here with the internet connection. Take care. Sorry for the weird stuff happening today. I know that hope you understand it was beyond my control. So I'll just pause for a second as some people depart. Take care, people. Bye, guys. Let me just answer these ones independently here, and I'll post the solutions on YouTube, okay? Let me post the solutions on YouTube after. Yeah, let's do that, okay? So I'm just looking at my desktop here to make sure that I've screenshot the correct ones. Yeah. Oh, my YouTube, Mike, it's Random Math Guy. Yellow logo. Yeah, sorry, Denny. I feel you there. I'm thinking something's up with Rogers or something. I don't know what area you are in, but I'm in the Midtown, and it's like garbage right now, the connection. Okay. Anyway, thank you so much. I'm going to record these answers just on my own. Okay, so I'm going to do a few more questions here because we had some technical issues with the internet connectivity today. So in this question here, we're trying to find several angles on this figure. And just to be clear here, this angle here is 23 degrees. And this angle down here is 32 degrees. So using property number 7, we know that this angle is the same as this angle. So this angle here is also 23 degrees. And same thing here, because we have the two tangents, then the middle line segment will cut this angle in half, meaning this angle here means that these are the same. So this is also 32. Now you might be noticing here, I didn't really talk about any of these angle measurements yet. My plan of attack for this question is just to fill in the figure and fill in all the angles and then deal with it later. So let's go through this figure and try to get some more stuff. So we have here 23 and 32, and this angle here, we can find it by using the 180-degree rule. These three angles add up to 180 degrees. So if you do 180 minus 23 minus 32, then this angle in here is going to be 125 degrees. You can approach it similarly to get the angle B here by using the overall figure. So we have this gigantic triangle here, ABC, which I'm just loosely drawing here. So we can get this angle up top here by noting that this stuff here plus this stuff here plus this angle here is 180. So what I'm going to do is add these two angles together and I get 46. And if I add these two angles together here, I get 64. So then this angle here at the top, excuse me, this angle here is going to be 180 minus 64 minus 46. So if you subtract that all out, you get 70 degrees. Now, each of these angles are the same. So if you take 70 and divide by 2, you get 35. So those angles are both 35. So let's clean up that figure a little bit now and talk about the inside. So over here, we have another triangle, this triangle right here. So this triangle has to add up to 180. So if we take 23 and 35 and this angle in here, those angles add up to 180. So 23 and 35 is 58. If you do 180 minus 58, you get 122. This angle over here, you could use 360 degrees, or you could use those two angles with 180. I'll use the 360-degree rule. So these angles that I'm circling here must total 360 degrees. So if you subtract 122 and 125 from 360, you get 113 degrees. That pretty much irons out the question, because now it's a matter of just using the labeling of the figure to figure out all of the missing angles. So let's just take that list of angles and repeat it down here. And we'll use the figure to navigate to get those values. So this is a matter of using the three-angle letter designation. And we'll just go systematically through the figure here. I'll just maybe use a different color for that. So maybe a nice green here or something. So angle OAC, OAC, trace it out with your fingers. OAC. So that angle is 23. Whoops. Now the next angle is AOC. Changing the letter ordering changes the meaning of the angle tremendously here, completely. So AOC is this angle, and that's 125. And then ABC is the overall angle here, which is 35 and 35, or 70. Then we have AOB. So AOB is from here to here and up. So that's the 122. And finally, BOC is this angle here, which is 113 or 113 degrees. So obviously I went a little bit quicker on these, but feel free to always go slower and definitely pause the video and try the intermediate steps at your leisure. Let's go through another example that we ran out of time for, which was this one. I just want to emphasize here, there's a letter here that you might not be able to read. It's a Greek letter called beta. And the approach here is to find that angle beta based on the polygon that is attached to it. So the first thing that I would do is focus on this shape here. This shape here is a four-sided figure. So we know that this shape here that I'm checking off is four sides. So if we use the formula n minus 2 times 180 to get the total interior angle, we know that n equals 4. So we know that the total angle on the inside of this figure is equal to 2 times 180, or 360. So now we have a budget of 360 degrees. I'm going to call this angle here x, just outside here. So we know that x plus 10 plus 40 plus 90 is 360, because those are all the angles that are on the inside of that four-sided polygon. So just to highlight them for you, there's four angles on the inside. There's the 10, which is this one here. There's the 40 over here. There's the 90 over here. So 10, 40, 90, there they are. And then you have x here on the inside, which is over here. So you can solve for x there, and I'm just going to state the answer for the saving a little bit of space here. You get 220 degrees. Once you have 220 degrees there, then it's a matter of solving for this angle here, beta. Now that rule we saw earlier in the previous question because it's an angle bisector, or in other words, this angle here is based on two tangents. Therefore, if I draw the third line segment, it cuts the angle in half. So this angle is the same as this angle. So that's beta as well. So we have 2 betas plus x equals a total of, well, what's this angle here? That's a revolution. So that's 360 degrees. So we can plug in all of the numbers that we have in the question. So we know what x is. So x is 220. And that equals 360. So I'll just state the answer for beta, which is 360 minus 220, which is 140. And then you divide by 2 to get 70. So there you have it. 2 algebraically oriented questions. Nothing too dangerous, hopefully. And I'm sorry that we had those technical issues, but maybe another question here to make up for it, a little bonus question here, a little extra. In this case, we're trying to find the length here of A, and all we're given is a length from here to here of 2.5 inches. So the question is, how the heck do you get A? Well, I'm going to draw a property of a circle on the side here that is related to number 7. If you have two tangents on a circle, then the side lengths, as those tangents converge, they form this shape here, and they'll have the same length. So I can apply that property several times to this figure. So let's take a look over here. This length here equals this length here. See, those are the same, using the property I just mentioned. I can also apply the property over here, like that. And that's a big milestone in the question, because that line segment is 2.5 inches. So anything I mark on the figure with 2 ticks is 2.5 inches. I can go over here and do the same thing. See, 2.5 inches. And then for the larger circle, maybe a new color is warranted here. Let's go with this color here. There's also 2 tangents going this way. So there's 2.5 inches this way and 2.5 inches that way. And there you have it. The answer for A, this length here, is 2.5 plus 2.5. A equals 2.5 inches times 2. This question is purely based on patterning and images and is such an elegant answer. So hopefully you enjoyed that example as well. And that concludes the extra questions I wanted to cover.